Hey everybody, it's been a little while since I've done a video. As you might know, I've released a few build guides, and one of the recent ones was the NAS Killer 4.0. And the NAS Killer 4.0, I've done something a little bit different, and I've outlined a lot of different options for motherboards, CPUs, RAM, SSDs, hard drives, power supplies, cases, everything. So instead of just recommending one board, it's just going to be kind of pick what you want, and it's going to be more of an overall guide as to what you can expect price-wise and performance-wise from the different components, as well as just trying to give more options, because we've been running into issues where a guide comes out and then the motherboard sells out, and then a lot of people are left wanting, some sort of replacement option. So the NAS Killer 4 is going to be a general socket LGA1155 guide, which that's going to be second and third gen Intel Core, i3, i5, i7, and first gen E3 1200 and second gen E3 1200. So it's very, very capable. There's really only one limitation, which I'll talk about in a minute, but this is a really, really good generation of hardware. And as some of you might know from back in the day, the 2600K was a great CPU, the i7 2600K, and that overclocked great. It's got great performance. A lot of people still run it today and still use it in their gaming rigs. But it's getting a little bit long in the tooth, but that's where building a server and building a NAS with these components comes into play, because the prices are dropping quite a bit. So in front of me, I've got two motherboards, and this one's going to be the really popular one. They're both Acer boards, but they're OEM'd by ECS. These come out of Acer pre-builts, and the nice thing about these is that they're standard micro ATX, and in this case this one's standard DTX, so I'll talk about that in a second. But let's just talk about this one. This is the Q77H2AM, and like I said, with a pre-built you don't really run into standard micro ATX. You might run into a different power supply connector, you might run into a different board shape, and maybe a different layout, so where the socket's on this side and the PCI Express is on this side. Dell, HP, Lenovo, they can kind of do whatever they want. I guess Lenovo is really not as bad as the other two, but the pre-built vendors, they can do whatever they want. So it's nice to see that Acer is just using off-the-shelf stuff. So I was able to pick this up really cheap, because this isn't sold on the market as a motherboard to buy, just throw a system together. This is sold as a replacement board for a very particular system, but it just happens to be able to be used like anything else. So that's kind of nice. And there's total full support for it, and drivers and everything. So it's really nothing different. It's just Acer branded. So that's pretty cool. This guy is just the mini version of this. So they make a mini tower. Well, I guess this is the mini tower, and they make this like little micro tower, and this guy's only has two PCI Express, one 1X and one 16X, and a couple other things that are like cut down, so it doesn't have as much USB, it doesn't have as much SATA, or as many SATA, but yeah, it's just, the cool thing about these is that they're cheap, they're standard, and they work great. This is pretty much going to be the standard recommendation for this build, for the baseline, the entry level, what I would call the core build. This board runs for about $24. $24, that's nothing. That's really nothing. It's so cheap. And then you can throw in a cheap processor, a $20 processor, and then a couple sticks of RAM, and you're at maybe another $30 for 8 gig or $40 for 8 gig. And then you have a pretty good NAS. And that's just a basic NAS. And then if you really want to crank up the power and add a lot more power, you can go from the i3 to the i5 to the i7, and you can push it up to the 3rd gen, which will get you even more processing power, like the i7-3770 or the 3770S, and I believe they're both around like 10K pass mark, which is pretty dang good. So yeah, I'm just gonna do a quick tabletop with this board here, and I wanted to show you this one because I thought it was pretty neat, at least the size of it. So this guy actually has standard mini ITX mounting holes. So that's the one here, 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 and here. But it's a form factor that you probably haven't heard of, maybe you have. It's called DTX, which means that you've got one more expansion slot to the right, and you've got a little bit of extra length. Now there's another form factor that's called mini DTX, which is like mini ITX. So you don't have the extra length here, but you have this extra slot. So this one is a full-size DTX board, and believe it or not, there are cases on the market that support DTX. As far as I know, any micro ATX case will support DTX, because really it's just the length of a micro ATX board, but it's not quite the width of a micro ATX motherboard. So DTX is cool if you got a special use case for it. This motherboard is not really any cheaper than this guy, so I just bought one just to check it out, but yeah, it's there. So if you want to do a little one, there's also mini ITX options in the build guide. There's also full-size ATX options in the build guide, but for the most part, I think most of you will probably end up with something like this, or the Supermicro X9, see if I can remember this, X9 SCL or the X9 SCM. Those are a little bit more expensive. They're about double the price of this, which might sound like a lot, but it's really only 50 bucks because this is 25. So the X9s are cool because they can run Xeon processors with ECC. So that's something to think about. And I guess that kind of segues us into the RAM discussion. And this is really the only limitation of this more of a consumer desktop style NAS. Now, you need to look at the specifications of your motherboard and the processor that you're using to see whether it supports ECC RAM. If you want to run ECC RAM, you have the option of running ECC or non-ECC UDIM, which means that it's unbuffered, not registered, regular DDR3. So here we have UDIM, and it looks the same as your RDIM, but the difference is that UDIM is much more expensive. It's not quite as available on the aftermarket like RDIM is. There's tons of surplus of RDIM. So the price of this per gigabyte is much, much lower, and unfortunately you cannot use it with this socket, period. It doesn't matter whether you're using a Supermicro board or this Acer ECS board, you just can't use it. So there's plenty of RAM options that are outlined, and because you're stuck with UDIM of some sort, whether it's ECC or non-ECC RAM, you're going to be stuck with a maximum of 32 gig, which might not sound like a lot if you're used to the Lego build or the Anniversary build, or let's say the NAS Killer 2, where that's more of a dual Xeon setup and you can have up to 512 gig of RAM or whatever. 32 gig is not a whole lot, but if you think about it, say you give 2 gigs to each VM, I mean that's quite a few VMs. Unraid doesn't really use a whole lot of RAM. FreeNAS will use whatever RAM you throw at it, so that's kind of a moot point. But 32 gig is pretty good. You know, it's more than you have on most gaming desktops. They're about 16 gig is the going rate nowadays. So it is what it is. But that is really the only limitation of this outside of you know, just whatever processor you can put in it. So just keep that in mind. So make sure you buy UDIM, and all that's listed in the build guide. So the biggest thing with this build guide is checking compatibility, because even if it's the same socket and say it's a similar motherboard, just do yourself a favor and double check. I've linked all of the specifications from the manufacturers themselves. Never use third-party specification websites. Intel Arc or your motherboard vendor's website, or the RAM vendor's website. Just look. It's not going to hurt you to do that and just double check compatibility. I've already done this with all of the suggested builds that are in the build guide. So if you're curious about those are all verified to be compatible with each other, so you don't have to worry about that. Just to get onto the tabletop part of this video, I know I've been talking for a little bit. There's not really a whole lot you have to do. Take the motherboard out of the packaging, and in this case, this guy just came with a paper cover for the CPU socket. Not the biggest fan of that. I much prefer these actual plastic covers that protect it. But you know what? It's a $25 motherboard. If it doesn't work, you'll get a refund and get a new motherboard. And they have plenty of these in stock, so it's really not going to be that big of a deal. Just take a quick inspection of the pins, and everything looks pretty good. And with your processor, you have two different ways of identifying how to put it in. This guy is a i5-3570, so it's just a quad core with no hyper-threading, but it does turbo pretty high. I think the base is 3.4, but I'm not really sure the turbo is probably like 3.9 or something like that. So it is pretty fast, especially in single core speed. But for typical NAS things and Plex and Dockers and whatever you want to do, it's going to be plenty. So sorry, a little sidetracked. There's two ways you can identify how to put this in the socket. You have notches here and here, so on one side of the processor, and then you have a gold triangle. Now the gold triangle will line up with a white triangle on the motherboard, most likely, or there's a cutout, a little like 45-degree cutout in the socket itself, so that's where that triangle would go. Or you can look for these little nubs that stick up here, and that's where it sits. So with this guy, you just kind of want to handle it by the edges and gently drop it straight down. And then we can close our socket door and push the arm underneath the latch. And that's all you have to do. These motherboards, this Acer, you might notice that it has standoffs already, like you might see on a Xeon motherboard. Well, they do, and that's because it was used before, and they had CPU coolers installed, so you had this bracket. But if you're using the Thermaltake Gravity, or pretty much any other CPU cooler, you probably are not going to be able to use this bracket that's already installed. They're not too hard to remove, but you do want to be careful when you do it, and I would make sure that something's in the socket, or at least one of these plastic covers are on. I wouldn't, if it comes with this, make sure you put your CPU in the socket first before attempting to remove this, because it'll protect the socket. You don't want to, they're just double-sided tape onto this metal bracket. You don't want to take a screwdriver and pry it off, because you might damage the motherboard if you slip, or if you're pushing on one of the surface mount components. What you can kind of do is take two thumbs and push from the standoffs, and that god-awful noise that you hear is the glue separating on the double-sided tape. You can kind of do this on the other side and just kind of wiggle it back and forth. And then if we do that enough, we should be able just to start pulling from this back end. Just pull gently and slowly. If you hear it making noise, that means it's coming off, so just do that. And then this double-sided tape is, I don't know, you can leave it on there if you want, or try to remove it. It's not a big deal. So that guy's out of the way. And our thermal take, I love these things. I like Arctic fans a lot, and they're great. They make a, I think I put this in the guide, I might have to update it if it's not there already. Arctic also makes a really, really cheap CPU cooler that's also very good. I think this one's just a little better. It might be a little bit louder though, but this one definitely has a little bit more cooling capacity than the Arctic one. But I think the Arctic's $9 and this is $9 too. So here's the back plate that comes with the thermal take. As you can see, has much shorter standoffs, so we're gonna use this one. And this guy can pretty much handle any CPU that you throw in the socket, so long as you don't overclock it. And that's another option with these boards. Probably not this Acer because it's just an OEM one, but a lot of these boards do support overclocking. How good they are at it, you know, your mileage may vary, but it's just something to think about. Yeah, so long as you're not overclocking or doing anything crazy, this should be plenty for even, you know, the i7 3770. Maybe I would suggest something else, maybe a little bit nicer of a cooler, maybe like the Arctic Freezer 12 for 20 bucks. But you know, it is what it is. So these have 2 holes in the top and 1 hole in the bottom, and you just kind of line that up with the screws that go through the bottom. You can just hold it with your hand. We're going to pull this fan wire off. So we're probably going to put it like this so that there's not a whole lot of fan wire there. You can kind of wrap the fan wire around to the CPU socket. And use this to just hold the back plate on. What you want to do is try to evenly torque these as much as possible. Just a little bit on each one in a cross pattern. And it should be able to be tightened down all the way until the screw stops. You really can't over tighten this, but don't try. Just tighten it down until it stops. That's it. And you might notice I didn't put thermal paste on. This guy comes pre-applied with thermal paste. If you want to use extra thermal paste, I would recommend removing what's on here and then using that. And I've done that in other videos, so if you need to know how to do that, you can check that out there. But again, for most builds with this guy, just throw it on and it'll be a lot easier. It'll save you some money too. So that's where our CPU fan is. I'm gonna try to tuck this wire sort of underneath, maybe just down a little bit, keep it out of the way. All right, so that's that. And then we have our sticks of UDIM here. This is just 2 4-gig sticks of 1333, nothing crazy. And on our board, we should look for, look at these motherboard, or the DIMM slots on the motherboard. Okay, so these are labeled DIMM 1, DIMM 2 in the blue slots, and then 3 and 4 in the black. So we're gonna use the blue slots. Every motherboard's different, so just pull out the tabs. You're gonna look for your key. So there's a short side and a long side, and here we have a short side and a long side. Do the one closest to the processor first, so that nothing's in the way. And you would take the short side, push straight down take the long side, push straight down. You shouldn't have to push in on the clips for it to seat properly. So just push it in, straight down on the left side, straight down on the right side. That's it. So pretty much done. Now you can test everything on your test bench and what we call in the Discord rule 0, which means build and test outside the case. So we've done the building. Now we need to do the testing, which would amount to hooking up a power supply. And really all you need to do to hook up a power supply, 24-pin ATX into here, and either your 4-pin or your 8-pin CPU power up here or wherever it's located around here. Once you plug those in, plug your power supply into the wall. Check to see if there's a on-off switch on the back of your power supply. This is something I've run into quite a lot. The on-off switch is a switch. It is not a button. The switch provides power, but does not provide a power signal. So that means it doesn't turn it on. The motherboard might turn on depending on what the BIOS settings are, but it is not a power button. It is a power switch. So that is something to keep in mind. So when you turn that button on and you plug the cord in, probably nothing will happen. And I can't tell you how many messages I've gotten over the years, the 2 years now, that people were saying, oh, well, my motherboard's not turning on. I'm like, okay, did you hit the power button? Like, yeah, I pressed it on the PSU. Well, that's not really gonna do anything because you're just giving it power so that it can receive a signal to turn on. And in this case, you're looking for a front panel header. These are USB, this is front audio. There's a BIOS little jumper thing here, chassis intrusion, and here's the front panel. So what you're looking at is a series of pins, and really you have to refer to your motherboard's manual. But 2 of these are your power button, 2 of them are your reset button, 2 of them are like hard drive LED, NIC LED, things like that. So all you have to do is just take a screwdriver and say it's these first 2. Hopefully you can see this. You just have to jump them like this. Just create a little bridge and that should turn it on. Again, it's going to be different with every motherboard, but every motherboard has a front panel header like this. Where it's located and which ones it is different per motherboard. So that's all you have to do. That's pretty much it for a tabletop build and testing it. So building and testing outside the case. Once you get it hooked up, power it on. Well, obviously plug in a monitor, mouse and keyboard if you want to, but really don't need to. And just get this thing tested before you mount everything in the case. Say you have a bad motherboard or something like that, you don't want to mess around with that in the case. If your board is bad, you're going to have to take it out anyway, and that's a pain in the ass because you just spent all that time putting it in and then you have to spend all that time taking it out. I do this. I build and test outside the case with all the systems I build. It just saves me a lot of time, a lot of hassle. Yeah, same thing if you have bad RAM. It's harder to get into the case, to swap the RAM sticks, and do everything like that in there. So just do it on the test bench, and you'll save yourself a lot of hassle. As far as everything else on this board, and I'll just talk about this one in particular. This guy's got 2 SATA 3 and 4 SATA 2. The SATA 3 we're going to use for SSDs, like cache drive, things like that on Unraid. The SATA 2, plenty fast enough for hard drives. Any regular hard drive will not even fully saturate a SATA 2 connection, so don't worry about that. You'll get plenty of speed out of those guys. So this guy, natively you can hook up, let's say 4 hard drives, 2 SSDs, or if you're not using cache for whatever reason, it would be 6 hard drives. And then you have more PCI Express if you want to add in a LSI 9201 8i, like a SAS HBA, you can add 8 more drives. There's a lot of expansion options with this, so you can kind of do whatever you want. But that's the cool thing about building your own NAS, is that it gives you the freedom to pick and choose what you want, and you'll have quite a lot more power for quite a lot less money spent. There's a very interesting post on our forums right now where a guy is going from a Synology, I think it's a DS something or other, to a NAS Killer 1. So this is a NAS Killer 4, it's a newer socket, better hardware, faster hardware. But he's going from a Synology to a NAS Killer 1. And he's already seen about a 30% improvement in read and write speeds alone, not to mention the performance of like actually having a real processor. So it's well worth your money, and you know, if you want to make a smarter financial decision, if I can talk, instead of spending $800 or $500 on a Synology, maybe spend $175 on an 8-bay NAS Killer 4 and see how that does for you. So I don't think there's a whole lot else for me to talk about. I've already talked quite a bit and not really done a whole lot. Oh, one thing I did want to show you, I think these are really cool. Now, this is not exactly a NAS Killer, but it's another product from Acer. This one is the Acer Veriton, I think it's like the, let's see, L4620G. And this one is the same socket as this, so it's LGA1155. And there's a reason why these are cool. And the reason is that they're very, very cheap. And I got this one for $30. And you say, okay, well, $30 doesn't look like a whole lot. You're right, it's not a whole lot. There's not a whole lot to it. But it's a full desktop socket. You can take any processor that goes in this and put it in here. That includes the i7-3770. The only downside is that you have very little space, very little expansion. I didn't put a CPU back in here. But this uses DDR3 SODIMM, and it does not accept the ECC, but you can just use regular DDR3 SODIMM, which is pretty cheap, up to 16 gig in this guy. I think newer versions can go up to 32. 2.5-inch SSD or 3.5-inch hard drive in this upper bay here, and then this guy is the heatsink for processor. Like I said, it's got a full desktop socket in here, and then there's two little 60mm fans at the back. I mean, this thing is dead silent. It's really, really cool. So you put this heatsink on like this, kind of like this, and with the lid closed, the fans just pull in cool air through the front, across the heatsink, and warm air right out the back. Now, these are cool because you get a motherboard, and this guy in particular has USB 3.0 on the front, and audio. You get a motherboard, sometimes you get RAM depending on who's selling it. One hard drive slot on the front. There's actually a, my right screwdriver. There's actually a, get this guy off. Actually a wireless card built in, so you can tell this is meant to be used as a desktop. There's also a mSATA port down here, so you can add an mSATA SSD down here and a regular spinning hard drive on the top. So maybe you want to use this for a little virtualization box, and I mean, it doesn't have dual NIC or anything like that, so you're not going to be doing pfSense. There's no way to add a PCI Express NIC, but maybe you just need another box for a little bit more power, or you want to separate off some of your downloading services or something like that into a separate box, and you can do it for very, very cheap. You know, those things, they don't need a lot of RAM, they don't need a lot of horsepower, and you're worried about, you know, sapping all the power from your main machine. Maybe you have something like this and you're just like, I just need a little bit more. You know, maybe I need 4,000 passmark and I don't want it to touch any of this that's going on here. This can store my data, this can serve up media, or it can, you know, I can record files from my stream or my streaming computer to this or something like that. But I don't want any of the processing like my VMs or my Dockers or anything like that. I don't want it touching my NAS. So maybe you can buy one of these and then you hook it in through Ethernet, you know, through your switch and through your network, map all the drives, and you just have more processing power for really, really cheap. So I think these are pretty cool. I guess the last thing I would have to say about this is that it uses an external laptop style power supply, but those are so ubiquitous. It's a 19 volt up to 150 watt, anywhere from like 80 to 150 watt. And it just plugs into the back. So I use my Dell G7 gaming laptop power brick for this, and that's 180 watt, and it works great. So they're very power efficient, very small, and you can create a nice stack of them, say if you wanted a little compute cluster or something like that. But space efficient, they're just straight up cool, and they're very cheap. So even cheaper than this, but unfortunately there's not a way to add a lot of hard drives to something like this. There are other larger pre-builts that are in the pre-built section of the guide where you can add hard drives, and you can, what I would call them a NAS, but one hard drive, it's not really a NAS. So anyway, that's the Veriton L4620G. Oh, and this guy has a CD drive too. There's a little CD drive down here, and that pops out. Oh, the other thing is, depending on which one you get, say you get a newer one, a 4th gen or a 4th gen or a 6th gen or 7th gen, some of the newer ones, they're actually very, very good at emulation. So if you like doing N64 stuff and PS2 and of course the older stuff, NES and whatever, this is a great little box for it. Really good home theater PC too, now that I'm thinking about it. These don't do 4K, but they do 1080p just fine. So you just 1080p right out the back into your TV, and then you've got the front ports for a remote or something like that. And then, like I said, they are dead silent. They don't make any noise. Just something to think about. I do talk about these in the guide a little bit, but I think we're done here. I don't really have much else to talk about. If you have questions about the NAS Killer 4, I know the guide's been out for a while. Please ask in the forums or ask on the Discord. Or, if you want to still use Reddit, go for it. I'm not going to cut anyone off of Reddit. I know people are a little miffed about me saying that I want to move things over to the forums. The forums are just better laid out. You can search for things, you can interact more, you can have a build log, say you're building something and you want to share it with people. You can just post it there, and people can constantly interact with it instead of trying to find your Reddit post, and it's not the same. Reddit's not designed for that sort of thing. So please just check out the forums, even if it's just you're just browsing, just visiting. We're happy to have you. There's the new Anniversary 2.0 guide, which is in progress, is out for donators. I appreciate all of you that donate to me. I appreciate everyone that doesn't donate to me as well. But if you do want to donate, you do get early access to guides and to anything that's happening behind the scenes. If you don't want to donate, I totally understand, and I will never make anyone donate. All content will eventually be released for free at some point. It's just a matter of when, when I can get to it. So it is what it is. But thank you to everyone, and this has been a good 2 years so far. Hopefully we have another great 2 years ahead of us, and I'll see you guys next time. Peace.